Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to do a Unit 3 review for you. So, 5 common methods to produce electricity: magnetic, chemical, pressure, solar, or thermal. So the magnetic method of producing electricity is actually the most common. It's through electromagnetic induction. And there are a couple rules of magnetism. We will explore this further down the road in the course. Electromagnetic induction: whenever you pass current through a conductor, you will generate magnetic flux or a magnetic field about the conductor. And if you were to move a conductor in a magnetic field, you would generate a voltage on that conductor provided it's in motion. Chemical, the most common example would be a battery. Pressure, most common example is a quartz crystal. It's actually called the piezoelectric effect. And the piezoelectric effect, if you were to have a piece of quartz, and for example, if you were to hit it with a hammer, it would generate a voltage at the ends of the quartz crystal. Likewise, if you apply a voltage across the ends of the quartz crystal would vibrate or oscillate. Solar, the most common method is photovoltaic, and very popular topic these days. If you drive around, you may see solar PV cells on roofs. What ends up happening: photons from the sun are absorbed by a solar cell in the solar PV array. Those photons are converted into electrons, and it actually produces DC or direct current, and then all of the solar PVC cells that are tied together are fed into what's called an inverter, and the inverter converts the incoming DC voltage into an AC or alternating current voltage for use. And the last would be a thermocouple. And a thermocouple: two dissimilar metals that are brought together at a junction will generate a voltage. I want to talk a little bit about batteries. The schematic symbol for a standard cell is represented here. Notice there's a positive and a negative terminal. When you combine cells together, you form a battery. And again, a battery has polarity, a positive and a negative terminal. So two connections that we use for batteries would be a series connection and a parallel connection. So in the example for the series connection, I give you two 12-volt batteries connected in series, and each of the batteries have a 10 ampere hour rating. So for the series connection, the voltages add and the current remains the same, because as we will learn in a series circuit, voltages add together but current remains the same. So 12 volts plus 12 volts would give us 24 volts. The current rating, or the ampere hour rating of the battery, remains at 10 ampere hours. And lastly, the parallel connection: when you connect two batteries in parallel, again, I have a 12-volt battery here and I have a 12-volt battery here. Each of the batteries have a current rating of 10 ampere hours. So in the parallel connection, the voltage remains the same, but now the current changes. So 12 volt in parallel with 12 volt gives us an output of 12 volts in parallel, but now 10 ampere hours plus 10 ampere hours gives us an overall current rating of 20 ampere hours. Thank you.